Good morning, everyone. This is going to be our first video in the Precalc series. We're going to be discussing what a function is. My name's Meek. I'm going to be teaching your class way better than your teacher can. With all that being said, let's get right into the video. So first and foremost, what is a function? Let's discuss this by first showing what a function looks like. Function is often represented as f of x. This is a function of x, okay? But it can be represented as any letter. It could be represented g of x, h of x, j of x, so on and so forth. Okay, so functions are used to demonstrate a relationship between y, or f of x, and x, wherein you plug in x into a function as your input, and you get out y as your output. Okay, so examples of functions. So you could say f of x equals 3x plus 2. Now this could also be written as y equals 3x plus 2 because we treat those two the same. If we treat x as our input, we're inputting a value x into this x variable. Like let's say we want to plug in 1, and the function is going to take in the input and it's going to spit out an output, which is our y. Okay, it's basically like a computer in that sense. So if we plug in our input as 1, 1 goes into the function, and in that case, I would replace my x with 1 for this particular case. Okay, so 3 times 1. 3 times 1 is 3. We bring down our plus 2 equals our y. So in this case, our y equals 5 when x equals 1. And you're going to get a different output, presumably when you put in a different input. And now the reason functions are important is because we represent them on a graph. So on our horizontal axis, our x-axis, we represent our input, x. In our vertical axis, we represent y, or f of x. Okay? So when we plug in 1 to our function, we're going to get out some y value, y equals 5. So this point right here is called an ordered pair, 1, 5. Okay, what is an ordered pair? An ordered pair is a pair of coordinates on the graph, and that pair of coordinates is specified by the function f of x right here. Okay, an ordered pair specifies one particular instance where if I input x into my function, I'm going to get out y. Now, moving on from there, we have the discussion of function tables. What is a function table? It's a table that looks like the letter T, like this. On the left-hand side, you have your input, x. On the right-hand side is your output, y. And a function table specifies for what inputs do you get what outputs. If I put in 1, I get 2. If I put in 2, I get 3. If I put in 4, I get 2. If I put in 4, I get 3. Whatever. A very important thing to realize when we're dealing with functions is what is a function and what is not a function. In order for something to be considered a function, an x value cannot be mapped to two different y values. The best way I like to explain this is if I have a kid and he's in school, okay? I cannot tell this kid to go to 2 different classrooms at the exact same time. Okay, the analogy here is that the kid is your x and the classrooms are your y. I can't split the kid in half and send him to 2 different y values. I can't send him to 2 different classrooms. However, if instead I had 2 children and I sent them both to the same classroom, that's perfectly okay. That's possible. I can't just split a kid in half. So the analogy here follows that 2 x values can be mapped to the same y value, but 1 x value cannot be mapped to 2 different y values. If you want to remember the analogy, just think, why do we go to class? So if we apply that reasoning to our function table right here, you say, okay, 1 is mapped to 2, 2 is mapped to 3, 4 is mapped to 2. So here I have 2 different x values and I sent them both to the same classroom. That's okay. I can do that. However, I have 2 of the same x value right here and I'm splitting them up to 2 different classrooms. That's not okay. It means this isn't a function anymore. So this fails the test. This is not a function. Which brings me to the graphical way of representing this, which is the vertical line test. So if I were to draw a graph of my function, if the function were to look like this, I would simply just need to draw a vertical line through it. And if the vertical line touches any more than once then it's not a function. Here I touch exactly once and nowhere else. It's a function. In this case, parabola. I draw my vertical line here, here, anywhere. I touch only once. It's a function, passes the vertical line test. However, if I were to draw us something like this, then I draw a vertical line here. Look, I fail the vertical line test. Not a function. Okay, now let's discuss the types of functions we have. First of all, we have linear functions. Now, you should have covered linear functions in your study of algebra, because they are in the form y equals mx plus b, where x is your input, b is some constant, and m is your slope of the line. We're going to have a separate video discovering slope. Okay? So, the steepness of the line, as we should remember, is determined by your slope. Okay? So y equals 2x would be this line, for example, and y equals regular x might be the lower line, for example. Next, we have the quadratic function, also known as the parabola. Okay? Parabola is in the form y equals ax squared plus bx plus c, where a, b, and c are constants. And the reason we write a, b, and c is because a doesn't necessarily equal b. They're not necessarily the same constant. Then you have the cubic function, which looks a little something like this, which is in the form y equals ax to the third plus bx squared plus cx plus d. Then you have the radical function, or the square root function, which looks like this. The reason I'm demonstrating these all for you is because it's important for you to be able to recognize them when you see them, in the form y equals some constant a times the square root of x. Okay? Following that, we have the logarithmic function, which is looking like this. Okay? And that is y equals log base a of x. Okay? Base a could be anything. It could be log base 10 of x. It could be log base e of x, which is equal to the natural log of x. We're going to have a whole video discussing logarithms, so if you don't understand any of these functions right now, don't worry, we're going to have dedicated videos on them. So I highly suggest you go watch those if you feel like you don't recognize some of these. Next, we're going to move on to exponential functions, which are in the form y equals a to the x. Which is not equal to x to the a. Okay, a is a constant. X to the a would be like x squared. That would be a parabola. We're not looking at that right now. We're looking at a to the x, which looks like this. Next, of course, are our trigonometric functions. We're going to have a whole video dedicated to the trigonometric functions and basic triangle trigonometry. Okay, these are going to be your oscillatory functions. They repeat up and down, back and forth, like this. Okay, and they continue on both sides of the origin. Now, this would be a graph of y equals sine x, but we can also graph another trigonometric function, y equals cosine x, so you can see the difference. You'll notice that they are exactly the same, just one follows slightly behind the other. Next, we have the absolute value function, y equals the absolute value of x. Now, if you don't know what absolute value is, whatever is inside the absolute value bars has a negative deleted from it. So the absolute value of 1, there's no negative, so nothing changes, equals 1. The absolute value of negative 1 has its negative deleted, so this equals 1 as well. Okay, so that's why the absolute value bars can never produce something that's negative, which is why you see nothing in the bottom two quadrants. Next, we have rational functions. Very detailed video coming up on these. These are probably one of the harder topics. So if we were to draw a rational function, it would look something along the lines of this. Okay, and it would continue on to infinity. Y equals 1 over x, or some constant a over x. You'll notice here that the graph sort of diverges away from this center line right here, and that center line occurs at the origin at x equals 0. So what can we interpret from that? It means that when we plug in 0, we are dividing by 0, 1 over 0, and we know we can't have that, which is why the graph sort of strays away, diverges away from that, and we asymptote. If you don't know what asymptote means, we have a very detailed video on that coming up. Next, and certainly not least, is the polynomial. Let me draw a particular one for you right here. This one is a 4th degree polynomial, which means it has x to the 4th plus something times x to the 3rd plus something times x squared plus something times x plus e, some constant. So we already hinted on this a little bit before, but we should also clarify how to evaluate functions. If we're given an input, we need to know how to find the output. Okay, let's say I give you a function f of x equals 4x squared plus 2x. Okay, so I say, what is the value of my function when x equals 2? Okay, that's going to be my input. So what do I do with this? I see x equals 2 and I go find everywhere x is in my function. Okay, I see x here and I see x here. That means I'm going to plug in the number 2 wherever I see that. So I'm going to bring my function down here and I'm going to rewrite it as f of 2, because I'm plugging in 2 into my function. That's the way we denote that, that's the way we show it. When we plug in some number, we plug it into the little parentheses here. So f of 2 is going to be equal to 4 times, we're plugging in 2 for x squared, plus 2 times, what's our x value? It's going to be 2. Okay? So now we just evaluate this. We say f of 2 equals, what's 2 squared is 4. What's 4 times 4? 16. Plus, what's 2 times 2? 4. Therefore, f of 2 equals 20. Alright. Again, guys, if you need help with anything, join the Discord server. Enjoy life. Thanks for watching.